Okay, we've covered the present value of a single cash flow. However, in a business context, cash flows often come in streams. Just like a stream that winds through a yellow wood, a cash flow stream refers to a series of cash flows received over several periods. It's important to feel comfortable with finding the present value of a stream of cash flows because, in a corporate context, an investment in a project will typically lead to multiple periods of cash flows. So, to find the present value of a stream of cash flows, the first step is to determine the present value of each individual cash flow. This is an important step because only cash flows in the same time period can be compared. That is why we must convert every cash flow to present value, so they can be properly compared to one another. Once you have discounted all the future cash flows to its present value, then you can sum the cash flows together. If we wanted to view this in a formula, it would look only slightly differently than for a single cash flow. It looks very similar, except that you must discount all future cash flows to the present value before summing. It's important to note that this formula is assuming consistent cash flow for every period starting in period 1. However, this might not always be the case because cash flows happen at uneven intervals. Therefore, we need to be really careful about what n we are using to discount our cash flows. Let's put it into action with an example. You just won the Powerball jackpot of $1.9 billion. Hooray! You're given two options for payment. One, a lump sum received today for $929.1 million, or two, an annuity or annual payment of $63.3 million every year for the next 30 years. They got $63.3 million by taking the $1.9 billion jackpot and dividing it by 30 periods. This is going to be paid at the end of every year. If the current interest rate is 4%, what option should you choose? Okay, let's hop over to our Excel template for this. Here at the top, you have your interest rate, and here you have your payment schedule of $63.3 million every year for 30 periods. Here is where we're going to fill in the present value of the two options. However, we already know the present value of the lump sum option. Since it's $929 million received today, the present value of it is just $929 million. So we actually have to calculate the present value of the payments option, or option number 2. And then down below, I'm going to show you an Excel function that makes this way easier. Okay, remember, our first step is to calculate the present value of each individual cash flow. So to do this, I will use this equation right here. I will type equals the cash flow at time 1, which is this, divided by 1 plus r, which is the interest rate, raised to the nth power. I'm going to make sure to lock my reference to r because I'm going to be using the fill handle, but everything else can stay dynamic. I hit enter, and there you have it. That's the present value of $63 million received in 1 year with a 4% interest rate. Now we can use the fill handle to click and drag this over for the remainder of our years. And when we let it populate, we actually see that the present value of the $63 million in 30 years is way lower than the present value of time 1. This makes sense because $1 in 30 years is worth way less than $1 next year. Okay, so returning to the left side of our spreadsheet, to finally find the present value of option 2 here, we simply have to sum these numbers. So I'm going to type a simple sum function, and then sum all of these numbers, close my parentheses, and hit enter. And there you have it. The present value of the payments option is $1.094 million, which is higher than the present value of the lump sum option. Therefore, we should take option 2, the payments option. Okay, when there's consistent payments like there are in this example, you can actually use Excel's present value formula to calculate the present value of all the payments in just one function. In this cell here that I've dedicated to it, let's type equals PV, open parentheses, choose this as our rate, enter in 30 as our NPER because we're over 30 periods. The payment now is this $63 million because that is a consistent payment received over every period for the 30 periods. And we actually don't even have to enter in anything for our future value. We can just close the parentheses and hit enter. This gives us the right number, but our answer is actually negative again. Once again, this is because Excel is calculating how much we would need to invest today in order to get the $63.3 million payment every year for the next 30 years. However, we're receiving it, so I'm going to go ahead and negate the payment, hit enter, and there you have it. Excel, in one easy function, is able to calculate the stream of a consistent cash flow for us.